Alright, this is 2.4, and this is going to be solving radical equations graphically. So there's going to be a lot going on here, and I think a lot of it depends on how much you remember from last year, those last 3 chapters, 5, 6, and 7. If you're good at graphing, this shouldn't be a big step up. If you struggled last year or you didn't get all the information you did last year, there might be some gaps in knowledge. I'm actually going to go through all my videos and upload, or rather release all the stuff. So if you do struggle in the graphing department, go back and take a look at the grade 10 chapters 4, 5, and 6. And hopefully that will give you a quick summary of what's going on. So basically, to solve any equation that has a radical in it, you basically have to first rearrange the equation so that the radical is by itself on one side of the equation and everything else is on the other side. Alright, so once you've separated an equation where you have one root on one side and everything else on the other side, you're going to graph each equation or each side of the equation as if it were 2 functions. You then want to see where they cross. Wherever they cross, that is going to be the solution to your equation. I think the best way to do this, especially if you're showing this video to the class, would be to pause at a certain point, let the kids catch up, write this down, and keep going from there. So we're going to use that first example of root x minus 2, keeping in mind that this is still underneath the root. However, the minus 1 is not. This is going to equal 0. So we first start by rearranging. This one's going to be easy to rearrange because I'm going to take my plus or negative 1, I'm going to add 1 to both sides, and what will happen is I'm going to have root x minus 2 equals positive 1. That's step 1 done. I now have to graph this. Now, again, this is where graph paper becomes almost vital in this class, where you makes life a lot easier if you can graph these on graph paper. So we'll make a very simple graph here. And this is where we do rely on some knowledge from last year for actual graphing. Basically what I'm going to do is I'm going to have set each one as a function. So I'm going to have y equals root x minus 2. I'm going to have y equals 1 as my 2 functions. Now y equals 1 is easy to graph. If you recall graphing your x-axis and your y-axis, so we have our x and our y. If y equals 1, y will equal 1 the entire time. So I go, from 0, 0, my origin, I go to 1, and basically y will always be 1. So I'm going to use a different color. I'm going to try and see if the red works now. So basically, everywhere where y is 1, we'll have a line. Wow, this pen is terrible. Purple. So this is our first function, and this is essentially where y equals 1. Our second one is a little bit trickier to graph. You will learn some tricks later on how to graph radicals, but for right now, your best luck is a table of values. So if your x and your corresponding y value. Just like last year when we have our root x minus 2, start with some lower values and go from there. So if I say, let's go 2, 3, and what's a good one? I will start with there. So essentially when x is 2, I'm going to have 2 minus 2 and the root of that. So 2 minus 2 is 0. The root of 0. The root of 0 is 0. So when my x is 2, so when x is 2, so 1, 2, my y is going to be 0. Okay. I'm going to pick when x is 3, so I'm going to have y equals 3 minus 2 equals, and 3 minus 2 would be 1, the square root of 1 is 1. So when x is 3, y is 1. You technically can stop there, we know where they cross, but just for sake, we'll pick a number that's nice and easy. Let's go with an extreme example. 2, 3, 4, 5. Let's go 6. 6 will work. So the square root of 6 minus 2 is 4, and the square root of 4 we know is 2. So when x is 6, so 2, 3, 4, 5, 6, my y would be 2. You'll notice very quickly that because it is a root, it's not a linear function. This actually goes into a parabolic shape. But what we care about is where they cross, which is right here. So the solution, where root of x minus 2 minus 1 equals 0, our solution would be when x is 3 and y is 1. So the solution, x equals 3, y equals 1. And if we put this in coordinates, it would be 3, 1. All right, clear as dirt, right? So as we do another one of these, biggest thing is just remember that you isolate and you try to graph. So for this next one, and make sure this is nice and centered. There we go. So we're going to have the example of the square root of 3x plus 1. Please note all under the radical. And we're going to have plus x. This is going to equal 9. So again, step one is always to put your radical on one side. So step 1, radical is essentially alone. So in our case here, we're going to take this positive x, we're going to subtract x from both sides, and we're left with root 3x plus 1, and I'm going to be left with, just graphically, I'm going to put my negative x out front. I'm going to have negative x, and this is going to be positive 9. Okay, now I set each of these to a function. So we're going to have y equals root 3x plus 1, and we're going to have y equals negative x plus 9. We do this specifically for a reason, because remember last year we had slope-intercept form. Which is basically y equals mx plus b, right? M being your slope, so in our case the negative 1 is our slope, and our b, which is positive 9, is our y-intercept, where we cross the y-axis. So draw your graph, and we're going to graph our second function first. So we know via slope-intercept form we cross the y-axis at positive 9. Positive 9, and I have a slope of negative 1. So if my slope is negative 1, it's really 1 over 1, and if you recall last year, slope is the same thing as your rise over top of your run. My rise is negative 1, I'm going to go down 1, and then to the right 1. Down 1 to the right 1, and this continues all the way on. So my first function, when I graph it, looks like this. This is essentially y equals negative x plus 9. Graphing our second function, a bit harder. Again, we will show you guys shortcuts later on. We want to make sure you understand the fundamentals before we overwhelm you guys with the extra work above that. So again, table of values, we have an x and a y. I'm getting a phone call. Hang on. All right, back. So make a table of values of x and y. And again, just kind of brute force the way we solve this. So pick a couple values that in your mind will be easier to solve. So 0 is good, 1, 2, 3, 4, 5, so on and so forth. The best thing to do is when you solve this, write your equation. So 3 times 0 plus 1. 3 times 0 is 0, 0 plus 1 is 1, and the square root of 1 is 1. So when my x is 0, my y is 1. Do the same thing. 3 times 1 plus 1, so what is the square root of 4? The square root of 4 is 2, so when x is 1, my y is 2. I'll use it for 2 as well, so 3 times 2 would be 6, plus 1 is 7, the square root of 7. And for this one, you know what, I'm going to let you guys use your calculators. We could try to find the perfect squares, but in most of our mathematics, this isn't going to work out super well. So the perfect square of 7 is going to be 2.65. And when you graph this, we're going to have x is 2, and it's going to be roughly about here. I did peek at my timer here, and I'm close to that 12-minute mark, which is when YouTube makes things not fun. So, jumping ahead, 3 times 3 is 9, plus 1 is 10. The square root of 10 would be 3.16. So about here. If we have 4 to our equation, we get square root of 13, which would be 3.6. And when x is 5, we know that our y value is 4. We can stop there. You could keep going if you wanted to, but once we know where they cross, that is our solution. So our solution is basically going to be when x is 5 and our y is 4. And again, it's good to always have this as a coordinate. So we're going to have 5, 4 as our solution. All right. So for this, the homework is going to be on page 137, and it's going to be questions 4 and 5, only A, and you try question 6AB. If you still want more practice with this, actually the biggest thing is if you're struggling with the graphing portion of it, I want you to go back and check out my specifically chapter, it should be 6 videos for graphing. Probably the first 2 or 3 where we're talking about slope-intercept form and solving by graphing. And then you also want to check out chapter 7, the later half, where they're talking about solutions, where you're basically trying to find out where the graphs cross. Just to give you guys a bit of an update, I will not be back probably until Thursday at the latest, or the earliest. So as regards to this chapter, you only have 2.5 left, and then we're probably going to have a test on, this is the Thursday class, so you guys will probably have the test on Monday. Your grades are, as far as your chapter 1 tests, should be posted tonight on my ed. And then if you have any questions, feel free to email me, and we'll work from there. If you have any concerns, again, also please email me. Otherwise, good luck.